Have you ever wondered how we determine the mass, volume, and density of a substance? Well, wonder no more. Firstly, let's dive into mass. Mass is the amount of matter in an object. The International System of Units, or SI unit, for mass is the kilogram. Other units include the gram, milligram, and ton. Now, how do we measure mass? For solids, we use a balance. For liquids, we measure the mass of the empty container, then the mass of the container with the liquid. The difference gives us the mass of the liquid. And for air, a gas, we use a gas syringe to trap it and then use its volume and density to calculate its mass. Next, we have volume. Volume is the amount of space that a substance or object occupies. The SI unit of volume is the cubic meter, but we also use liters and milliliters. To measure the volume of liquids, we use a measuring cylinder or a pipette. For regular-shaped objects, we use mathematical formulas. For irregular objects, we use a method called displacement, where we measure the volume of water displaced when the object is submerged. And for air, we use a gas syringe to measure it directly. Now onto density. Density is the mass per unit volume of a substance. The SI unit of density is kilograms per cubic meter, but we also use grams per cubic centimeter. To find the density of solids, we divide the mass by the volume. For irregular sinking objects, we use the displacement method to find the volume, then divide the mass by this volume. For irregular floating objects, we use a slightly different method involving the displacement of water. For liquids, we find the mass of a known volume and divide the mass by the volume. And for mixtures, we find the mass and volume of each component, then add these up to find the total density. Relative density is simply the ratio of the density of a substance to the density of a reference substance, usually water. Because it is a ratio, relative density has no units. It can be obtained using the same methods as density, and it has various applications from determining the purity of substances to predicting whether an object will float or sink. Finally, density and temperature influence ocean currents. Warm water is less dense than cold water, so it rises, while cold water sinks. This creates a current. There are two types of ocean currents: surface currents caused by wind, and deep ocean currents, caused by differences in density and temperature. So, in summary, mass, volume, and density are key properties of substances. They are measured using various instruments and methods, and they have many applications from everyday life to scientific research. Understanding these properties can help us make sense of the world around us.